everyone, this is Aslam Shareef, Assistant Professor in Physics, Lord's Institute of Engineering and Technology. Welcome back to lecture series of lasers. Today we are going to discuss a concept called Einstein A and B coefficient in laser series. So as you can see here, we are going to discuss Einstein coefficient and relation between them. Einstein coefficient are mathematical quantities which are a measure of the probability of absorption or the emission of light by an atom or molecules. So here we are discussing the quantity based on the absorption and emission phenomena. So consider two energy level or and of an atomic energy system E1 and E2 respectively such that E2 is greater than E1. So here we are giving a reference as two energy state one as ground state and energy state 2 as excited state. So here N1 and N2 be the number of atom per unit volume present at the level E1 and E2 respectively, and energy density radiation is given by E2 minus E1 is equal NH nu is equal rho of nu, where rho of nu is representing energy density. So here E2 minus E1 is representing the change in two energy state, and NH nu is giving a reference with number of photon along with a Planck constant, where n is the number of proton, h is Planck constant, and nu is frequency. So in the first case where we are discussing about the absorption, as we have discussed previously, taking a reference in initially all the atoms are residing in the ground state unless and until an external photon of energy incident on it to make the atom get excited by absorbing photon of energy. So in this case one, photon of energy is being absorbed by the atom in the ground state and moved to the higher energy state such as excited state. This phenomena is termed as absorption. And in the stage 2, we are saying the atom which have moved to the higher energy state after spending its average lifespan of 10 power minus 8 second, the atom on its own coming down to ground energy state by emitting photon of energy. This is denoted by the equation h nu is equal to E2 minus A1. Whereas in case of stimulated emission, the third diagram you can see on your screen, where we are saying that the atom which is there in the excited state, taking a reference from the absorption, we are giving additional photon of energy. This additional photon of energy is being observed by the atom, and the stimulation is happening. Due to this stimulation, the atom is coming down to the ground state by emitting two photons of energy here. And these two photons of energy is in phase with each other. So this process is termed as stimulated emission. So let's discuss the independent and dependency based on stimulated absorption, spontaneous emission, and stimulated emission. Stimulated absorption. So stimulated absorption rate is proportional to incident energy density rho of nu of the radiation and the number of atom N1 present in the atomic system. Therefore, P12 is directly proportional to rho of nu n1, where P12 is representing the transition from lower energy state to higher energy state. Energy state 1, energy state 2. So probability of finding the transition from 1 to 2 is given as P12 and is directly proportional to the energy charge density rho of nu as the additional photon or the incident photon incidenting on the atom which is staying or being there in the ground state. So therefore the equation can be taken as P12 is equal B12 rho of nu n1. Say this equation 1 where B12 is Einstein coefficient of absorption and it represents the property of energy states. Let's see spontaneous emission. Spontaneous emission rate is proportional to the number of atom at N2 present in the excited state. So here P21 is giving a clear indication that the atoms which are present in the higher energy state is coming down to ground state. So the transition is taking from 2 to 1 is given as P21. So P21 spontaneous emission is directly proportional to N2. Therefore, P21 spontaneous emission will be equal to A21N2 where A21 is Einstein coefficient of spontaneous emission and it represents the property of energy state. So if we observe in the case of spontaneous emission, we does not require any external energy such as photon of energy. In this scenario, the atom on its own after spending an average lifespan of 10 power minus 8 second is coming down to ground state on its own. So therefore, we are giving the notation as A21 for spontaneous emission. Let's see stimulated emission. Stimulated emission rate is proportional to stimulated energy density rho of nu of the radiation and the number of atom N2 present in the excited state. Therefore, P21 stimulated emission is directly proportional to rho of nu N2. So here in this scenario, we are discussing a case of two energy state and the atom which is situated in the higher energy state is been bring back to ground state by a photon of energy. So the transition which is taking from energy state 2 to energy state 1 under the influence of external photon is given a notation as the charge density rho of nu. So P21 stimulated emission is directly proportional to rho of nu N2. Further, this equation can be written as P21 stimulated emission is equal B21 rho of nu N2. Give a reference as equation 3. Here, B21 is Einstein coefficient of stimulated emission and it represents the property of energy state and is known as stimulated emission B21 coefficient. The total transition probability of atom from stage 2 to stage 1 can be written as, we are taking a case of stimulated emission and we are taking a case of spontaneous emission. So here you can say that P21, the transition from higher energy state to the lower energy state under the influence of the atom can be taken down as P21 spontaneous plus P21 stimulated emission. So stimulated emission is happening under the influence of external energy of photon, whereas spontaneous emission is happening from 2 to 1 without any external energy on its own after spending an average lifespan of 10 power minus 10 8 second. This equation further can be written as P21 is equal A21 N2 from equation 2 plus B21 rho of nu N2 from equation 3. So we are giving a representation of spontaneous and stimulated emission transition from 2 to 1. The energy state 2 to 1 is given as P21 spontaneous emission plus P21 stimulated emission. Let's see the further. At equilibrium temperature, the number of transition from state 1 to state 2, that is upward direction, will be equal to number of transition from state 2 to state 1 downward direction. Therefore, the equation will be P12 is equal to P21. Considering the equation 1 and 4, we can write the equation as B12 rho of nu N1 is equal A21 N2 plus B21 rho of nu N2. Here, B12 transition from 1 to 2 is representing the absorption state, whereas A21 transition from 2 to 1 is representing the spontaneous state and B21 is representing the stimulated state. Let's take the row of nu common and take the equation in terms of A21N2. A21N2 is equal to row of nu. If we are taking common row of nu from here and here, the equation will be reduced to the form B12N1 minus B21N2. Now, let's write this equation in terms of rho of nu. So, rho of nu is equal to N2A21 divided by B12N1 minus B21N2. Now, from this equation, let's take B21N2 common in the denominator. So, N2 as it is, A21 as it is, divided by the common term we are taking here, N2, B21. Then B12 N1 as it is, since we are taking the common and it will comes to the denominator, the equation will be now B12 by B21 into N1 by N2 minus 1. So from this equation, N2 can be cancelled. So the equation will now reduce to the form rho of nu is equal to A21 by B21 divided by B12 by B21 N1 by N2 minus 1. Say equation 5. Now, according to Boltzmann distribution law, the distribution of atom among the energy level E1 and E2 at thermal equilibrium temperature T is given by N1 is equal N naught exponential minus E1 by KT, and N2 is given as N2 is equal to N naught exponential minus E2 by KT, where N naught is population in the ground state and K is Boltzmann constant. So the equation at absolute temperature thermal equilibrium taken with respect to T. So from the equation 5 and 6, we can write the equation as, you can see here, n1 by n2 is equal to exponential E2 minus E1 by kT. As we have seen, the difference of two energy state will be equal to h nu. So E2 minus E1 will be equal to h nu. Therefore, substitute the value here as E2 minus E1 h nu. So the equation now reduced to the form n1 by n2 is equal exponential h nu by kt. Now substituting the equation 5 in equation 6, we get this equation. Now according to we get the equation as rho of nu is equal to A21 by B21 divided by B21 by N21. In place of N1, N2, we are changing the equation with exponential h nu by kt minus 1. This gives to equation 7. According to Planck's law, the energy density of radiation is given by the equation rho of nu is equal to 8 pi h nu cube by c cube into 1 by exponential h nu by kt minus 1. So if you see the equation, this equation is been derived from Planck's law. Now comparing the equation 7 and equation 8, we can say that 1 by exponential h nu by kt minus 1 by exponential h nu by kt minus 1 can be taken as constant or can get cancelled. And from the above equation, equating B12 will be equal to B21. So as a result, if we are substituting B12 by B12, this get cancelled. We'll get the equation value as 1. So here we are saying B21 by B12 or B12 by B21 will be equal to 1. Call this as equation 9. So from the above equation, if we see that the value of A21 by B21 will be equal to 8 pi h nu cube by c cube. So the desired equation we got as Einstein A and B coefficient A21 by B21 is equals 8 pi h nu cube by c cube. This gives equation 10. So the above equation are the relation between Einstein coefficient. Let's see the conclusion related to Einstein A and B coefficient. So from equation 10, we have got the equation as A21 by B21 is directly proportional to nu3. That is the ratio of Einstein coefficient of spontaneous emission to stimulated emission is directly proportional to cube of the frequency of incident photon. Then the conclusion number 2 is the rate of spontaneous emission increases rapidly with the energy difference between two states. And the conclusion number 3 states from equation 9, we have derived the equation B12 is equal B21. That is, thermodynamically, it was proven by Albert Einstein that the probability of stimulated emission and absorptions are equal. Henceforth, they concluded as B12 will be equal to B21. In the coming series, we'll discuss about the main part of laser, ruby laser, helium neon laser. Thank you for watching. Subscribe for more videos.